여러분 안녕하세요. 저는 베라담 사장입니다. 잘 부탁합니다. Now, today I'm very happy to have an opportunity to introduce our technology, our products, and our application for device. So this is the agenda of my presentation. I'm starting with a brief introduction of our company, and then moving on to the presentation for technology. So I'll describe you, at first, I'll describe you the basic principle of Hall effect sensor. And next, I will talk about new detection principle of Hall sensor. And then I will show you recent application examples I'm using for the demonstration video. And finally, conclusion. So let me describe our company organization. Our company taking a holding system. And under the umbrella of the holding company, we have 4 categories with 9 independent companies. And we are doing a variety of business fields, which are chemical and fibrous, homes, construction, electronics, and healthcare. AKM belongs to electronics. We are here. Now please let me focus on AKM. We have made 3 categories, which are semiconductors, magnetic sensors, and fine pattern coils. Our strong benefit is to combine these different technologies and make something new. I think this is our company's strong point. So please move on to the basic principle of Hall effect sensor. This effect was discovered by Dr. Hall in 1879. And please look at this drawing. The current flux is bent by Lorentz force under the magnet field. And the direction of the Lorentz force is followed by famous Fleming's left-hand rule. And between these 2 electrodes, electromotive force happened because of the different density of the electron. So, therefore, we can obtain the output voltage from the whole element. This output voltage is in proportion to the magnetic flux density, like this graph. This shows the typical materials for Hall sensor, which are silicon, gallium arsenide, indium arsenide, and indium antimony. And the important performance of the Hall sensor is sensitivity and temperature dependence. And these 2 properties are strongly related to the mobility and band gap. In indium antimony case, it has high sensitivity, but it is not stable with temperature. In gallium arsenide case, it does not have high sensitivity, but is stable with temperature. There is no perfect materials. And our company, AKM, handle all kind of materials. And we can propose the suitable solutions depend on the customer's request. This is our company's advantage. So let me introduce our business. So our business started in 1980. So we have more than 30 years experience. And from a functional viewpoint, there is two types of Hall sensor, magnetic sensor. One is Hall element, another is Hall effect IC. In Hall elements, the worldwide share is more than 70%, and the production volume is more than 120 million pieces per month. Regarding Hall effect ICs, we have two types of structure. One is hybrid type, two chips inside within one package, and monolithic type. The production volume is more than 40 million pieces per month. So let's move on to the new detection principle of Hall sensor. We call this new technology magnetic concentrator. So please think about the magnetic flux. Magnetic flux is a vector quantity, and it can be divided into three axes: X, Y, and Z component. And when we put Hall element into the magnetic field, the Hall sensor can detect only a vertical component, and it does not detect horizontal component. This is a point. Due to these characteristics, there is some limitations for the application of Hall element. To solve this limitation, we put the magnetic concentrator on two holes. After the horizontal magnetic flux changed from horizontal to vertical. So we can detect the horizontal magnetic flux according to this formula, and we can calculate the intensity of Bx, Bz, also By. In addition, we can also detect the incident angle here, alpha, with this formula. This technology is applied to the angular sensor. So let's move on recent application examples. First of all, I will show you electronic compass. This is made with our magnetic concentrator solution. So this is a big advantage in package size. At the beginning, the package size was very big. And you can see three Hall elements here for X, for Y, and Z. No magnetic concentrator. However, the latest one with magnetic concentrator, we could make the package size smallest. And the volume of the latest one is about 2% from the original one. Big advantage. And the main application of our e-compass is a mobile phone and tablet. And the worldwide market share in 2012 is about 70%. This shows the strong point of our e-compass. we have three aspects: component, software, and support. Our component is made by one chip solution with silicon monochip die. So we can make the package size smaller and smaller. And big advantage of software is auto calibration. And regarding the support, we can suggest the better magnetic layout on the customer's system. And we can do it in worldwide on-site. So this sheet shows the technology roadmap. Existing service is a navigation system with 3-axis e-compass. And now our new technology trend is 3D fusion, 9D fusion, with adding the accelerometer and gyro onto the 3-axis e-compass. And as a future application with 9D fusion, we are discussing AR and PDR. Dead reckoning is a relative position technology. It calculates current position by using a previous determined position and travel distance and course, like this. And this sheet shows the benefit of PDR. Current GPS is available only outdoor. As an indoor service, we have network triangular. But its service, the support from infrastructure like Wi-Fi is needed. And this is strongly influenced by the RF condition. So the accuracy of this service is not very good. As a reliable indoor location service, we propose PDR. So I will show you the video, demonstration video. You will see these screens. This is reality. And this screen is a view of this lady. And this screen is per mobile phone. And this is top view of the building. So please enjoy the video. So this video is taken at our head office. So reality view of this lady and top view of the building. Now she starts walking. So turn right. Press also turn right. And turn left. Crossing lobby. Press following. And turn right. Press also. So very accurate, even in indoor. So please stop. So next application is single chip pulse encoder. This is also made with our magnetic concentrator solution. So first of all, I would like to explain the principle of this device. This device has magnetic concentrator, so it can detect both horizontal and vertical magnetic field. This is magnet, and this is Hall sensor. In here, the horizontal magnetic intensity is maximum, and vertical magnetic intensity is 0. And here, vertical magnetic intensity from S4 is maximum. and horizontal intensity is 0. So the vertical waveform is always in advance to the horizontal waveform in 90-degree phase. Here, opposite rotational direction. This case, horizontal waveform is always in advance to vertical waveform. So if we see which waveform is in advance, we can obtain the direction of the rotation. And also, we detect the rotational speed also. In conventional solution, to obtain the same information, we need two hole IC. And we have to adjust the pitch between two holes and magnetic pole. So please enjoy the video. This is an 8-pole magnet. At first, conventional case, we have two hole IC. According to the rotation, LED lamp also runs same direction. Now change switch. To our new technology, single chip solution. So same performance is obtained. Now we change the magnet to 16 pole. First overall conventional one. But this case, the pitch is not adjusted. So sometimes doesn't work. Now change to our new technology. So it's working smoothly. So I will summarize later. And I tried to another magnet type. It's sheet type, like this. And the same performance we obtain. So please stop. So feature and benefit of our single chip encoder. No need to hold IC, and freedom of the location, and smaller package, and pitch free. So works well with a variety of magnetic poles. So we have a lot of target application, especially for automotives. Window lifter, power seat, wiper motor, and several kinds of jog dials, and headlight arms. So let's move on to cross-position sensing. It means precise position sensing technology. Now CPS is getting popular among camera application. And there is two main usage, which are autofocus and OIS, optical image stabilizer. And the whole element is used to detect the position of the lens and CCD. And this is the principle of CPS. Depending on the location between magnet and Hall element, the output from the Hall element changes linearly. When S4 coming to the Hall element, output is here. When N4 coming to the whole element, output is here. Taking this linear field, we can detect the position of the magnet. And this is the layout examples. So example 1 is simple and good to detect with a short stroke. And example 2 is good to detect with a long stroke. Now I'll show you our demonstration video. This is existing technology. Here, our new technology. The important point is today's focusing method is have a spring, so it needs some time to stabilize the lens position. And our new technology, no spring, and the whole sensor detects the position and give the feedback system. So from here, it's mentioning about power consumption. So existing one, it needs much power consumption because of it needs a power against spring. So please stop. So last application is current sensor. There is 3 sensing methods, and we are taking DCCT with cost point of view. And in DCCT, there is 2 types of the 2 types. One is open loop type, and another is closed loop type. And our solution is open loop type. It has the advantage of the small size and good price. And this shows our current sensor's construction. Our current sensor is very simple with only 5 parts. And no adhesion is needed for the assembly process. And this is our big advantage. Our big advantage is fast response time. We have achieved only 1 microsecond, while the competitor takes 3 or 5 microseconds. This performance is achieved by using 3-5 compounds technology. So this is the application of our current sensor. This is the inverter case for the power factor control here, and vector control here, and overcurrent detection here. Our current sensor is used. And this is the power conditioner case. So current sensor is used DC current detecting and also AC current detecting. So conclusion. AKM has quite many options in production lineup and can provide customers with best solution with worldwide on-site support, following their requirements. And AKM is going ahead with new development like magnetic concentrator, and will expand the possibilities for new applications. Finally, let me introduce our group slogan. It is creating for tomorrow. Thank you very much for your kind attention. 감사합니다.